Hello everybody, this is Celesta Matthews and today we are going to see an experiment where we will be designing a single pass assembler. So what basically is an assembler? An assembler is a system software in which you give your assembly language as your input and you get your object program as the output. As you can see over here, this is a small program wherein you can add two values. So you have copy, which is the name of the program, start, and 1000. 1000 is your starting address. Now you have LDA alpha, that means you have to load your accumulator with alpha value and you have to store it into beta. That means you are just loading that value and storing it somewhere else. Now what are the two variables that you use? You have alpha and you have beta. So I have declared alpha as reserved word 1, that means reserved word will occupy 3 bytes, which is equal to 1 word, and beta will again have reserved word 1 and n. This means that your program has completed. Okay. So now what are the things that we need to do in order to convert it? First of all, we need your opcode table. Okay, so like a sample input is over here, STA, the opcode for that is 23 and for LDA it's 00. Other than that, you need your starting address. Now this is an SIC program and so each instruction will be of 3 bytes. So what I do is I write 1000 over here and then I need to increment it by 3. So for that we need a location counter so that we can fix the addresses for each and everything. Okay, and the other thing is that for this sample input you need a 2-pass assembler. 1-pass assembler will not work with it because 1-pass assembler has only a single pass, right? So when we traverse through here, it sees alpha, which it does not know what is alpha. After that it again sees beta and it does not know what is beta. After that the alpha and beta values are declared or initialized. Okay. Now the other two values on the top, they are still unknown, so you need a second pass in order to do that. So in single pass assembler, what we do is these two values we put it on the top, like after the start line, and then the instructions we will put down. So your output will be something like this. Okay, so you have a header, name of the program, starting address of the program, and then you have the size of the program, and then you have your text record, the starting address of the text record, length of the text record, and then all your object code will come over here in a single line, and you have your end record and again the starting address. So we'll see how the program is done. First you have a scanner object, then you're taking input for the number of lines, the name of the program. Okay, you have these variables over here. You have the starting address, then for string code you will have the input from the user, whatever the user will give, and then you have the input, that is, this is used to read the next token from the input that the user gave. Then you have the location counter, which is used to provide the address for each and every instructions. Then you have the input for the number of variables. Then I have the flag. This is used to mark if a variable is actually a variable or it's a mnemonic. Okay, then you have the size of the program, because you can see over here in the header record we have mentioned the size of the program. Okay, now after that we have the mnemonic and the opcode. These are two arrays. Now I have the opcode for LDA and STA, that's 00 and 23. You can add any more what you want. After that I'm asking the user to enter the number of lines and the number of variables in the like the assembly language program that is provided, and then okay, I think you can expand it here. Then you have the object program. Okay, and this will be your last output that I showed you. So for that I need the size of that particular string will be the number of lines minus the number of variables minus 2, and you have the number of variables, and that is also number of variables the same. This is used to store the variables into the symbol table. After that I have int addr, and this is used to store the address of that particular variable which I am entering into the symbol table. Okay. Now X is used to keep the count of the number of variables in the symbol table. Now I am running this loop in order to take the input from the user. So after that, for the size of the program, I say the number of lines minus 2. That means the first one will be the start and the last line will be the end. So I subtract both of them into 3 because each and every instruction is of 3 bytes. And after that, I say SOP, that is the size of the program. Now what I have to do is, once I get the size of the program, that will be an integer or integer value. I have to convert it into an hexadecimal value. So this loop will do that work. And after that, I have the string tokenizer object. Now in that, I have given the code as the input and I have given space as the output. That means it will differentiate based on the space. Now I read the next token, and inside the while loop, I'll run it till I have more tokens left. Then I say input is equal to st.next token, that is I take the next token, and after that I have over here we are assigning the name of the program, okay, which is mentioned, like copy was the name of the program, so we put it into a variable named name. Okay, after that what I will have is my start, okay, and here is the code for start. So I say ip.compare to start. If it is start, then what I do, I take the next token, which will be my starting address, and I assign it to a variable called starting address. I convert it into an integer because the string tokenizer will always return me string values. Okay, after that I print the header record and I say that the location counter will be equal to your starting address. Now the next time that I come, I'll be reading the assembly level program, right? So for that I have, like, the first value was, if I give the input over here, it will be alpha reserved word 1. Okay, so in that case what happens? It is not equal to end. So I come over here. Now if I say that if int I is equal to 0 and I less than mnemonic, now what I am doing is I am searching it inside the mnemonic and the opcode. Okay. So if I find that it is a mnemonic, then I have to replace it with the, I have to create an object code for that, right? So this will do that work for me. I'm searching in the mnemonic array, and then if I find that particular array, then what I do is I take the object code, that means I take the address of that particular value, and then I concatenate it with the opcode value, which is done over here, and then I increment the count value. Okay. Now if my flag is equal to 0, that means it is not a mnemonic value, it is a variable. So if it is a variable, I have to enter it into an opcode table. So this will do that work. Over here you have your address at x is equal to location counter. That means we are making an entry in the symbol table. Your variable is equal to the input that you have, and your address is equal to the current location counter. Now if compare to is reserved word, if I have a reserved word, then it's 3 into the number of words entered, and similarly it's done for word, reserved, byte and byte. Okay, so after that whole thing is done, I print the text record, and then using the loop I print the object program as well. That means this will be just the starting address, like the text record, the starting address of the text record and the length of the text record. Rest of the object program will be stored in your object program, the string array that we declared in the beginning, and that will be printed using this loop, and at the last you have the starting address. So we'll see the output once. Okay, they are asking for the number of lines, so here we have 6 lines. Next is number of variables, which is 2. Enter the input. Now for entering the input, I will say copy, let's put it in capitals, copy start 1000. Next I will say alpha reserved word 1. beta reserved word 1, then I'll say LDA alpha, and I will say STA beta, and the last line will be end. So you can see that your object program has arrived over here. Header, record, copy, starting address and the size, and again you have the same thing over here. So I hope you understood the program. Thank you.